Okay, so today's lesson is going to be about optimization problems. Now, an optimization problem is simply finding the optimal value for something. In other words, it's a fancy way of finding the absolute minimum or the absolute maximum of some sort of, geometrical shape, or it could be a financial problem, it could be any sort of physical problem in this case. So, two steps to solving optimization problem is that you have to understand the problem, and the second step is to draw a diagram. Okay, so today we're going to go with a simple problem, and it's going to be that you have a poster, and this poster has four sides like any other poster, and within that poster there is an area of print. Now, what's going to happen here is that the area of the print, we know, it's told us in the question, is going to be 384 centimeters squared. We would find the dimensions of the poster with the smallest area, but we was also told what these distances are here. And we were told that this is 6 centimeters, same with this, and these margins are 4. Okay, so once again, we want to understand the problem. So what we're trying to do is that we have a fixed area in here, and we know what these margins are out here, and what we want to do is we want to find the length of the tops and the bottom, the sides, that are optimized, that give us the smallest area. So, since we've already drawn a picture, we're going to deal with the idea that we have an area to start off with. So the area of any square is just the length times the height. In this case we have x times y. And for simplicity purposes, we will label this the height, this the width, and inside we'll let this be x and this be y. Okay, so if you have x and y, the area inside, we know it's going to be equal to 384, and we know that the height times the width is going to be equal to that y plus whatever those margins are. So in this case we're going to have 6 plus 6, because that's going to give us our total height, times the width, which is x plus whatever those margins are. In this case it's 4 plus 4. And that's going to be our total area. So what we have here is that we need to do some solving to figure out what some of these variables are. So going back to our area, we know that this is 384, and if we want to solve for y, simply divide both sides by x, and it's as simple as that. So going back in to a is equal a times w, it's going to equal x plus 8 times 384 over x plus 12. Okay, so now expanding this out is going to give us 384x over x plus 12x plus 8 times 384 over x plus 8 times 12. Simplifying this gives us 384 plus 12x plus 3072 over x plus 96. Further simplification will give us this to be left with, and now, since we have an actual equation for the area, and we know that we want to optimize the area to be smallest, we know that we have to set this equal to 0. And this concept comes from earlier on videos of finding the absolute minimum and absolute maximum values. So we know here, since we find the smallest area, we want to find the absolute minimum, and therefore we're going to set this equal to 0 and figure out what values of x are going to give us 0. So that is the trick behind these questions here, is that you're trying to set up and find some equation to represent whatever it is that you're trying to find, whether it's geometry or physics again sort of thing, and then what you're going to do is that you're going to take the derivative of that and equal to 0. So back a step, I had set the equation equal to 0, and what I meant is that we have to set the derivative of that equation equal to 0. So now that we have some equation, a of x, we're going to take the derivative of that, and if you remember what we had before, taking the derivative of that simply will give us, 1 minus 256 over x squared. And that is what has to be equal to 0. So essentially what we're going to do here is we're going to solve for the critical point. And in doing so, dividing by 12 gets rid of 12 on both sides, and that will leave us with x squared equal to 256. Therefore, the critical point is 16, and that's where our absolute minimum is going to be. So we know this because the derivative of the area of x component is less than 0 when x is between 0 and 16. Therefore we know it's going to be our absolute minimum. So now that we know that x is equal to 16, we now have y equal to 384 divided by 16. That's going to equal 24 centimeters. So, going back to our dimensions that we had before, we have our height times our width. It's going to equal y plus 12 times x plus 8. And that's going to give us 24 plus 12 times 16 plus 8. And that is simply going to give us 36 centimeters times 24 centimeters. And that is exactly what the question asks for, what the dimensions of this are. So that here we know is our y, and this is our x dimension. And that's how you solve for an absolute minimum problem in an optimization.